Hi everybody, welcome back. Today we're going to talk about division, long division with when you have to annex a zero, okay? And what that means is when you annex a zero, it just means you're going to put a decimal place in, okay? Your dividend. Remember, this is when you have a division problem, you have a divisor and you have a dividend. Let's put a 3 there. This is your divisor. That's not where you're going to put the decimal in, okay? If I need to add a decimal, what I mean is I annex a zero. That means I put a decimal. I always bring it straight up, and I add as many zeros as I need to as I'm going along the problem, okay? So that's how you annex a zero. That way, that's what you get to not have a remainder, because we are way past the remainder stage of math right now, all right? So let's try a problem. Let's do... how about we do 222 divided by 5. So 5 goes into 222, okay? I just picked a number out of the blue. This is going to be a terminating decimal, and I'm going to explain that when we're done, and then we'll write a little definition for it, okay? But I'm going to show you as we go through it. So when I'm solving this problem, I'm going to look at this and I'm going to say, okay, how many 5s go into 2? 0. I can either put that 0 up here or I can leave that blank. Okay, you can leave that blank. The only time you cannot leave it blank is if it's after a decimal. Okay, usually right before a decimal either, I wouldn't leave it blank. So I'm going to go on to my next two numbers. I'm going to go on with the two numbers. How many 5s would fit into 22 without going over? And that would be 4. Because 4 times 5 is 20, and then we're going to subtract that, and I get a remainder of 2. Remember, I'm only bringing down one number at a time. I'm going to use a little bit darker color pen because this one's not showing up too great. So I get a remainder of 2. I'm going to bring down my 2, just like we did with all the other division. Now, how many 5s go into 22? Well, we just did that, so we know it's 4. 4 times 5 is still 20. I'm going to subtract, and I have a remainder of 2. Go figure. Okay, so here's the part where you're going to annex the 0. I can't have a remainder, and it's not remainder 2. Do not write remainder 2 or 0.2. You have to put that decimal in and add a 0. I'm going to keep adding zeros until I either have a pattern, which is going to be a repeating decimal, or I get a 0 remainder when I'm dividing. Okay, so I'm going to bring down that 0. You are not putting the 0 up here. You are just putting it here, because $222 is the same as $222 and no cents, right? So I can put as many zeros after that, and it doesn't change the number. Then I'm going to start all over again. 5 goes into 20. Well, I know that's 4 because we just did that twice. 4 times 5 is 20, and I get a 0 remainder. That's what I mean by a terminating decimal. You get a 0 remainder. Okay, that means it's an actual number. I mean, it went in an actual amount of times. All right, let's try another one of these. All right, let's try this problem. How about, this one looks like it's going to be easy, and it actually is, but then it's going to be kind of different. So let's say 31 divided by 8. That seems pretty simple, right? Okay, so again, 8 doesn't go into 3, so I'm going to leave that blank. It always has to line up with the last number you use. So I'd say, how many 8s fit into 31? Well, I know 8 times 4 is 32, and that's too many, so it's got to be a 3. 3 times 8 is 24. I'm going to subtract that, and I get a 7 remainder. Perfect. But I don't have any more numbers to bring down. So here's where I annex my 0. I put a decimal, bring that decimal straight up, and then I put in a 0. Then I can bring a number down. I'm going to say how many 8s would fit into 70. Okay, so right off the top of my head, 8 times 9 is 72 comes into my head, and that's too big, so instead of a 9, it's got to be an 8. 8 times 8 is 64. Again, I'm going to subtract. I get a 6 remainder. Still have a remainder, so I'm going to keep adding my zeros. All right, I'm going to go all over again. How many 8s would fit into 60? Well, we just did 8 times 8 was 64, which is a little too high, so I'm going to go with 7. 7 times 8 is 56. I'm going to subtract that. And I get a 4 remainder. Still have a remainder. So I'm going to make my line a little longer, annex another 0. All right, how many 8s would fit into 40? Here we go. That's 5 times, because 5 times 8 is 40. So I end up with a 0 remainder, okay? So there's 2 examples of when you have a terminating decimal. That means that you get a 0 remainder. No matter how many zeros I had to bring here, I end up with a 0 here, okay? All right, let's talk about a repeating decimal. All right, so repeating decimal just means that you're going to have a decimal and it's just going to keep going. So you're going to find a pattern, okay? So you're going to see a pattern in your remainders, okay? All right, so let's do one. I'm going to start with one that is pretty simple. So let's say 2/3. If I have the fraction 2/3, that actually means 2 divided by 3, okay? We all know that 2/3 is less than 1. So if I divided that out the wrong way, I'm going to get 1 point something. I would know that was incorrect. My answer's got to fit what this was. It's saying it's 2/3 of something. So that means the 3 goes on the outside, the 2 goes on the inside, because it is literally 2 divided by 3. So remember, all fractions are division problems. Here is where I would put the 0 in, okay? Because it's going to be right before. I only have one number. So I would say 3 goes into 2 0 times. It doesn't go into 2. 0 times 3 is 0. I'm still going to do my subtraction. And I have a remainder of 2. Here's where I annex my 0. I put in a decimal. I bring it straight up. Add a 0. Bring down my 0. Now it's 3. How many 3s fit into 20? Well, 6 do. Because 6 times 3 is 18. 7 times 3 is 21, so that would have been too many. I get another 2 remainder. Annex a 0, bring it down. How many 3s go into 20? Well, we just did it, 6. 6 times 3 is still 18. And I get a 2 remainder. So hopefully you're seeing the pattern. It doesn't matter how many times I do this. I'm going to go in 6 times. I'm going to get a 2 remainder. So if I want to annex another 0, 3 goes into 20. 6 times 3 is 18. I could do this for the rest of my life and keep going. And it's never going to end, okay? So what I would do is I'm going to say, okay, well, this is a repeating decimal. It goes 6, 6, 6, 6, 6, 6, 6 forever. So my answer would be 0 and 6/10 repeating. So what that means is the 6 repeats, okay? I don't write a bunch of 6s. I don't write 0.66 repeating. I find the first number where it repeats, and I just put a line, the repeating decimal line over that, okay? So you got to remember that. You got to look at the numbers. So in other words, if I had something, let's say my answer was 0.271271, and that's my pattern, I would write it as 0.271. Here's where it repeated again. It was 271, 271, 271. So I got to put the line over all of them, okay? If I had a number like this, 0.8333, and it just kept going with 3s, my answer would be 0.83, just the 3 repeated, so my line's going to go over just the 3, okay? That means that it just goes forever with a 3. All right, we're going to do one more problem like this, and we should be good. All right, so let's try this one. 11s are always repeating decimals. So if I have 11 goes into, let's say 5,020. Why not? Come up with any number. Okay, so again, I'm going to estimate, if I don't know my 11 times tables, which we should, but I'd say about how many 10s would fit in there. And 10 would fit into 55 times. That's exactly 50. That's a little more than 10, so I'd go with 4. Or if I knew my times tables, I would say I know 11 would fit in here 44 4 times 11 is 44. So either way, I can either estimate or I can, if I knew my times tables, go with that. So I'm going to subtract. I get 6. I'm going to bring down my 2. All right, so again, now I'm going to start over. How many 11s would fit into 62? Well, 11 times 6 is 66, so it's got to be a 5. 5 times 11 is 55. Heck, 11s, they're easy. I'm going to subtract that. I get a 7 remainder. I still have a number to bring down. How many 11s would go into 70? Well, that's going to be a 6, because 6 times 11 is 66. And I get 4 left over. Now I have a remainder, which I can't have. So we're going to annex a 0. I'm going to make my line a little longer, though. Remember, when you annex a 0, you put the decimal here, you put the decimal here automatically. Okay, and then your 0 only goes after your dividend. We're going to bring that down. All right, 11 goes into 40. Well, I know it's 44 4 times, so that's got to be a 3. That's 33. I'm going to run out of room here. So I'm going to subtract, and I get a 7 remainder. Still got a remainder, and I don't have a pattern yet. So we're going to bring down another 0. 11 goes into 70 6 times. We did that already, so that's looking promising. 6 times 11 is 66. I'm going to subtract, and I get a 4. We had that already, too. 0. 11 will go into 40 3 times. I'm going to move my 40 up here because we ran out of room. So 3 times 11 was 33. I get a 7. I would bring down another 0 till I have a really clear pattern, and I'm going to have it after this one. 11 would go into 70 6 times. 6 times 11 is 66, and I get a 4 remainder. So it's going to keep going 3 6 3 6 3 6 3 6. So I would write that answer as 456.36, the line over both because both numbers are repeated. Okay, so real quick recap on this. When you annex a 0, it just means that you had a remainder, and you can't have remainders. We don't want R2 or remainder 4 anymore. That's elementary school. This is middle school. So because you don't go to a store and it'll be like, well, that costs you $54 remainder 2. That doesn't make sense. Okay, so we do everything with dollars and cents, and those are decimals. So I put in my 0, I put in my decimal, I bring that decimal straight up right away. Decimal, decimal, but the 0 only goes here. Okay, and I just keep adding zeros onto my number until I either get a 0 remainder, which is a terminating decimal, or I find a pattern and I get a repeating decimal. That means I find a pattern where it's just going to keep going and keep going and keep going. If I would have kept this problem going, I could go on forever, and I'd get 40. It would go in 3 times. Then I would get 70, and it'll go in 6 times. So it just keeps going. All right. So practice some division. It's really, once you get the hang of it, it's pretty quick and pretty easy to do. All right. Have a great day.